Hi Year 10, this is our third topic for Term 2, Coordinate Geometry. So the number plane consists of two perpendicular axes which intersect at the origin and has four equal quadrants. So basically a Cartesian plane. And when we talk about quadrant 1, 2, 3, 4, as you can see in that diagram there, that's where they are placed. And they don't change. So it always starts in the top right hand corner and goes anti-clockwise round. We can find the distance between 2 points if we plot two plotted points, we can find the distance between those. So if we have x1, y1, x2, y2, we can use this distance formula and it will tell us the distance between them. You'll see here the black line that's drawn on that graph, that is the distance between the 2 points that we're trying to find. So as you can see there, we can actually make that into a right angled triangle. And what we're actually using with that formula is just Pythagoras. So we find the distance of the bottom of the triangle, the distance of the top, squaring both of those, adding them together and then doing the square root. So just nice and simple Pythag. So example 1, find the distance between these 2 points. So what we're going to do first is recognise that x1 and y1, so we can use this one as x1, this one is y1, x2 and y2. Then we can just put those values into the formula. So we want the distance between A and B. So I'm just going to write AB because that's the distance we're finding, equals, and it's going to be the square root of x2 minus x1. So we're going to have 3 minus -2 squared plus y2 minus y1. So we're going to have 4 minus 1 and that all squared. If we work that out, 3 minus -2 will be 3 plus 2, so that will be 5 squared plus 4 minus 1 squared, so 5 squared plus 3 squared, which will give us a square root of 25 plus 9, which gives us the square root of 34. So the distance between those 2 points is the square root of 34. As we haven't been given units, you don't need to write them, or if you wanted to do, you can just write units. Example 2, we have a triangle that's formed by these 3 points, A12, B25 and C41. Now firstly we want to decide, is this triangle equilateral, isosceles or scalene? Then find out, is it also a right angled triangle? So if we look at this first, to work out if it's equilateral, isosceles or scalene, we can use the lengths of the sides to work this out. So obviously, if the triangle is equilateral, the distance between all 3 points will be the same. If it's isosceles, it'll have 2 the same and 1 different. And if it's scalene, they will all be different. So that's what we're looking for. So we need to work out the distance from AB, AC and BC. Okay, and then we can work out our points from there. So if we were to think about a triangle, we've got a triangle, we've got ABC, so we want to work out the lengths of each of those sides. So if we start with AB first, all right, we know it's going to be the square root of 2 minus 1 all squared plus 5 minus 2 all squared. Now it doesn't actually matter which one you have as x1 on y1 and x2 y2, as long as the 1s are in the same spot and the 2s are in the same spot. So we could have done 1 minus 2 and 2 minus 5. We'd still get the same answer if we'd made the B point the 1s and the A point the 2s. So if we work this out, 2 minus 1 will be 1 squared, 5 minus 2 is going to be plus 3 squared, which is going to be 1 squared plus 3 squared will be the square root of 10. And that's the length of AB. We're going to do the same for AC and the same for BC. So if we now look at AC, we'll get 4 minus 1 all squared plus 1 minus 2 all squared, and we'll do the square root of that, which will give us 4 minus 1. So we're going to have 3 squared plus 1 minus 2, which will give us -1 squared. 3 squared is 9, plus -1 squared is 1, so we're going to get the square root of 10 again. So we now know it's not scaling, so we're going to work out, is it equilateral or isosceles? And now we're going to do BC. So the side BC, we're going to have 4 minus 2 all squared plus 1 minus 5 all squared. And the square root of that. 4 minus 2 all squared will be 2 squared plus 1 minus 5 squared, negative 4 squared. So remember to put that negative 4 in brackets. Okay, otherwise you may get the answer wrong if you don't use brackets and you've used your calculator. So this will give us 4 plus 16, because negative 4 squared is 16, which will mean we get the square root of 20. So as we have two sides the same and one different, the triangle is isosceles. So we just need to write something to that effect. So since AB equals AC, the triangle is isosceles. All right, part B. Determine whether the triangle is right-angled. So to do this, we just use Pythag. So we know the longest side is going to be the square root of 20, and the two other sides will be the square root of 10. So we need to work out, is AB squared plus AC squared equal to BC squared? This is what we're trying to work out. Does this work or not? So AB squared is the square root of 10 all squared, AC squared is also the square root of 10 all squared, which equals 10 plus 10, which equals, so BC squared should equal 20, which means BC equals the square root of 20, which is what we had originally. So the triangle is right-angled. And to do that, because it's a proof that we've actually used a converse. We had all three sides and we were working out, is this true? So we used our converse of Pythag then. And then we just write a statement, something along the lines of, using the converse of Pythagoras' theorem, the triangle is right-angled. All right, and we have one more example, example 3. We want to find B, given that these 2 points A and B are square root of 13 units apart. Okay, I'm going to explain your results using a diagram. So we want to show that they are root 13 units apart. So what we're going to do first is we've got to work out what B is. So that's just going to be subbing values into our distance formula equation and solving it from there. So we're going to get the square root of 13 equals, because that's how far they are apart, x2 minus x1, so we're going to get b minus 3 all squared plus the y's, 1 minus minus 2 all squared. If we simplify this a little bit, square root of 13, we're going to get b minus 3 all squared. 1 minus minus 2 is 1 plus 2, so that's going to be 3 squared. Now, I would like you to pause the video here and I want you to give it a go at solving that for me and see what you get. All right, so pause the video now, have a go at solving that, and then start the video again and you'll see if you're correct or not. All right, hopefully you did what I asked and paused the video and gave this a go. So this is what you should have got. Now, because both sides are square rooted already, we can square both sides, which means we'll end up with 13 equals b minus 3 all squared plus 3 squared, which is 9. Minus 9 from both sides, we'll get 4 equals b minus 3 all squared. Now take the square root of both sides to get rid of that squared. Now this is where, if you've made a mistake, you will have gone wrong. Okay, so taking the square root of 4 means we could have had the plus or minus of 2 equals b minus 3. So I reckon in majority of you forgot to put the plus or minus. That means then to get b is going to equal 3, positive 3, the plus or minus of 2. Which means b, we're actually going to have two answers. We could have b as 5 and b also equals 3 minus 2, which is 1. Now you're probably wondering here, why is there two answers? And this is why the question says explain your result using a diagram. So if we looked at these points, because they are points, which means they are coordinates, so we can draw them on a graph. Okay, so here they've got some axes just quickly drawn. Now, if we're going to start plotting these points, if we plot point A first, because we have that, so that's 3 and -2. Now we've got two values for B, and you're probably thinking, wow, well, if you think about this, we've got B equals 5, so we've got the coordinate would be 5 and 1, and then we could also have the coordinate of 1 and 1. And if we think about this, here, it's fully plausible that that is root 13 units, but that could also be root 13 units. Which is why there's actually two answers to this solution, because you could go right from point A, or you could go left from point A and draw a line, root 13 units, up to the line where y is 1. Okay, that is the end of this first video. So this is exercise 9A. You can go on with that now. There's going to be a couple of questions like maybe example 3 where they may be slightly different, and it's really pushing your thinking and your understanding of questions. Okay? If you have any concerns, you're not sure about anything, just email your teacher.